Okay, I show it's 3 o'clock, so I guess we'll go ahead and get started. Welcome, everyone. Today our presenter is Hank. He's a cloud architect at David Kent Consulting, and I will turn it over to you, Hank.
Hi, thank you. And thank you everyone for joining. And go ahead and share out my desktop. Again, hello everyone, and thank you for coming to today's presentation. Your participation in Cohesion is really what makes this successful for all of us. And we really appreciate having prepared. I personally appreciate having prepared the 3 sessions and Friday's workshop. I learned so much just preparing that. And I'm learning so much from sessions like the one that Earl had earlier today. So let's go ahead and get started. Today's session is about hybrid cloud configuration management and orchestration using Ansible. Now, Ansible and Terraform both perform cloud orchestration, or the creation of what we call mutable objects in the cloud. But Terraform does not perform configuration management, nor is it designed to do that. So it's important to be aware of other tools that can do the orchestration, but also can do the configuration management, or be used just to do the configuration management. There, you've got Puppet, you've got Chef, you've got Ansible. I'm sure there's another one out there, but I just can't remember the names of the other ones that are out there. But those are the big 3 in the configuration management. And having worked with Chef, Ansible, and Ansible, I find that Ansible is probably the stronger product of the 2 that I've looked at for combining orchestration and configuration management. But before I begin, I'd like to go on mute and turn it over to Dave for just a moment. Dave, go ahead.
Thank you, Hank. I'll make this as quick and painless as possible. I'm David Kent, president of David Kent Consulting, and we really appreciate the opportunity to be here at Cohesion, the first ever virtual Cohesion Summit. We are a group of experienced Banner, Oracle, and cloud professionals who provide functional and technical services to higher ed. And our goal always is to help you get the highest possible return on your already very large investment in this beast that we call Banner. And so, you know, if we're leaving features sitting on the shelf, but if we don't have time to implement things, or if we're overwhelmed by manageability issues, then we're not necessarily getting the biggest return. And so we, working with our clients, we always focus on that return on investment. Our focus for the Cohesion Summit here 2020 is to help you bring a higher level of manageability to your infrastructure, seeking new, exciting and creative ways to make those infrastructure, the infrastructure much more manageable. Thanks, Hank.
Thank you. So when I started to write code to the cloud, this is how it felt. I'd run my code and the cloud would say, well, that code isn't any good. And by the way, here's a meaningless error that's not going to help you fix your problem with your code. It can get tough, but just, I thought I'd share a little bit of humor. Of course, I'm Daffy Duck. I'm always Daffy Duck on the left. So hybrid cloud computing in Ansible, what are we going to cover? We're going to very briefly cover the DevOps model. I'm going to be covering that in greater detail on Friday morning. We'll talk about Ansible, mainly Ansible CLI and the heart of configuration management. We'll briefly go over what Ansible modules or vendor plugins are. These are the plugins that are really the heavy lifter of running infrastructure as code when we talk about orchestration and configuration management. We'll go briefly into Ansible Tower / AWX. AWX is the free version, which from my perspective takes the CLI up to the next level. It fronts it with a GUI and allows you to integrate the Ansible technology into a CI/CD, continuous integration, continuous development type model within a DevOps culture. And I'll show you a brief demo of an application that we've set up for disaster recovery in the Oracle Cloud. Now, DevOps is, some may say it's a framework, some may say it's a culture, some may say it's a standard, some may say it's a tool. Really, it's, well, first of all, it's not a standard. Yes, DevOps is a cultural change in the organization. And yes, DevOps is the tools as well, and the people behind it. Without the culture change and without the people standing behind the change in the culture, the tools become meaningless. I'm going to quote this, which comes right from AWS. The DevOps is the combination of cultural philosophies, practices, and tools that increases an organization's ability to deliver applications and services at high velocity, evolving and improving products at a faster pace than organizations using traditional software development and infrastructure management processes. It's a mouthful. If you want to learn a little bit more about DevOps, come see me on Friday. I'm going to move on to the next slide. What is DevOps to my organization? Mark, one of the authors who's helping me and others on the cloud, the EDUCAUSE, ITIL, and DevOps working group, said it best, is DevOps is what you define DevOps as being right for your organization. There's no one size fits all. And Ansible is a tool that allows you to write code and then run that code to manage your infrastructure. It is agnostic to whether that infrastructure is on-prem, in Azure, Google, Oracle, AWS, SoftLayer, DigitalOcean. I could go on and on and on. For all of these cloud public service providers, or most of them, there are Ansible plugins that can serve as your point of ingress to build up, manage, and tear down cloud or on-prem infrastructure. And when we talk about on-prem, I'm including things like Cisco switches and firewalls, NetApp filers, compellent storage centers, et cetera, and so forth. Even VMware can be managed with Ansible. The use cases of Ansible, when we think in terms of a DevOps culture and a DevOps model in the organization, and I'm speaking more broadly, it's more than just the Ansible code, but also including Tower or AWX. Again, AWX being the free version, is you have on the left a representation of application development, network sysadmins, basically your infrastructure people, and management, which would include your change advisory board or your CAB or your change management group, whatever you would call that. And then at the core of it, you've got your Ansible CLI, you've got the plugin modules that come from the providers of the various infrastructure and application resources that you're managing. You write playbooks that, and you build templates and potentially external code, and I've done all three. And then you, within Tower, you then configure that to run those playbooks to either orchestrate or run configuration management or do both. And you can see that I've drawn these two rectangles, the vertical and the horizontal rectangle. The vertical rectangle representing cloud technology, and you see I've got 4 cloud providers in there. And then the horizontal rectangle representing the on-premise infrastructure. And so I'm prodding you to think about, well, when we talk about infrastructure as code, we tend to think, well, that's cloud. Well, that is a misnomer. Infrastructure as code is agnostic today when you're using a product like Ansible, Puppet, or Chef, or for that matter, Terraform if you're just doing orchestration. It's agnostic to whether you're on-prem or in the cloud. And this has a potential to have a profound impact on the IT organization, because when we look at the left-hand rectangle, specifically the woman representing a developer team and the man representing a network and sysadmin infrastructure team, we often don't think of that person in the middle of that column as being someone who writes code. Well, that role is changing dramatically. And more, we are writing code to drive our infrastructure. And we're doing less and less with GUIs like NetApp Data on Tap, that nice interface you get to manage your filers. And now we can write applications that can sense an event in either on-prem or in the cloud. And as a result of that event, it can kick off a trigger that can that can run a playbook that can take an action based upon that event, whether that be a loss of service, an increase in workload demand. We can dynamically manage our on-prem and our cloud infrastructure. I'll hereby refer to as our hybrid infrastructure as code, and it can be elastic and grow and shrink capacity based upon what our situation and what our workload requirements are. Now, of course, the difference with cloud versus on-prem is that on-prem, you're buying that capacity and it's a finite amount. Whether or not you use it, you're going to pay for the consumption of that resource, or you've already paid for the consumption of that resource. Whereas cloud is an OpEx, or an operational expenditure model, and you only consume what you use in the cloud, presuming that your contract with your cloud provider is not written to be over the capacity that you're actually consuming. The organization of Ansible Tower in general is you build organizations. For instance, in a large organization, you might have different divisions of a company. You might have upstream oil and gas, for instance. If we look at a company like EOG, you might have upstream development. You might have transportation for getting natural gas from the field to a storage facility, et cetera, and so forth. So there might be different organizations within a larger organization that need to be created, or you might take the approach, which is more classical from my perspective, of I create organizations that represent a particular suite of projects that I am a number of projects. But you might have a network group, a network infrastructure group. You might have an app development team that's doing just banner, and therefore in Ansible Tower, you might create 2 or 3 organizations that represent what your organizational structure is. The inventory is where you have either individual hosts or groups that are representations of what you're managing, the actual objects that you're managing. So for instance, you might have several Ansible nodes that are being managed by this Ansible Tower application, and each node, you might have a node just for managing your on-prem storage. You might have a node just for managing your Oracle Cloud. You might have a node just for managing Azure. And so that would represent the inventory. Or the inventory might be solely on the Ansible Tower with Ansible CLI installed on it. And then you might be managing 50 or 60 or 70 Linux machines. You might be managing your Kubernetes cluster, your Docker cluster. You might be managing Tomcat directly from Ansible Tower. Then you build teams, and teams represent this previous page, where you might have 2 teams within your development organization. Say, for instance, you might have a team that manages just your SharePoint and your O365 infrastructure, and you might have a team that manages development for Banner. So you might have 2 teams there, and you might have a team that covers all of your systems and infrastructure. So in your organization, you might have 3 teams that would be created with credentials clearly for each team member, and then for the team, and then even granular to individuals, permissions that come with those credentials. And you can build within Tower workflow so that code runs through its cycle in pipelines. And I use that term generically, so that the code, when you get your code, you push it up to Git, you pull it down into Tower, you seek your approval, and then it flows through to another team that could be your ITIL group. Or it could be, if you're doing, if you implement a DevOps model, it could be the manager of development, who then says, well, was your code tested? Okay, I see that you tested your code. Oh, I see someone who's your peer also tested your code, and both of you certify that that code is good to go, and the level of risk with that code is really low. Okay, I'm going to go ahead and approve that change, and it's going to push out to production right away. Or it could be that there's a higher risk threshold, in which case I'm going to approve that, but I'm going to flag that, and that's going to have to go in front of the CAB for approval. And then, of course, we talked about projects where you organize your code into a variety of projects. So I might have a project for an initial migration of Banner to the cloud. And then for that same organization, I may have a subsequent project 6 months later to set up disaster recovery in another region for that organization. So I would create a second project just for that. I might have a third project to manage scaling out and scaling in the Kubernetes cluster and managing the Fortinet web application firewall as an example. So all of these would be projects, and all of these projects would have code written behind that would actually manage that infrastructure. And within the project, I have that organized in the form of playbooks. Playbooks actually run the job, and then job templates, which isn't just another form of code that represent reusable codes. So I might have a template that creates a machine instance in AWS. But then I'll have a playbook that might create 10 machines for, or 20 or 30 machines for a computer science class. And so when it comes time for that class to spin up, then I have a schedule that's going to call that playbook. It's going to run that playbook, and it's going to build those virtual desktops for that classroom. The professor walks in and everything's ready to go. And then in jobs is where I would actually create those jobs and schedule those jobs. And then they would run either manually or automatically. This is a screen print directly from the Ansible website, which shows a dashboard. And you can see that we get a nice graphical view of the hosts, the failed hosts, meaning these are the hosts I can talk to, these are the hosts I cannot talk to. I don't know why their inventory number is so low, but these demos don't always align with what reality is versus what they're showing you. But you say you got your inventory. I don't know what the sync feature is. I've never used that. Projects, and then project sync failures, and just a quick touch point on that. With projects, you typically synchronize your code to some type of software repository, and the first one, of course, that comes to mind is GitHub, because that's what pretty much everyone is using. And then, of course, you have the ability, both at the command line, looking at the log files manually, or within the graphical tool, you can look at your jobs and you can see what the result of a job was, whether or not it was successful or if it had failed. It's not at all different from a touch and feel versus tools we have already grown accustomed to using in our industry. And then you have workflows, and workflows or the workflow visualizer. And the workflow visualizer is where you actually would build a series of tasks that would then manage your infrastructure and build it out or modify it. And we'll talk just a little bit about the thinking behind that, one mode of thinking that you could apply behind that as you start to consider using infrastructure as code to drive your hybrid infrastructure. And here we've got a screenshot of what a project looks like. This is a demo that I actually set up earlier this week for today's session. And demo project you get when you initially install Tower. You notice it says AWX. AWX is the free version. At the very end of the presentation, we'll talk about what Tower costs and what you get for that price versus AWX, and the opportunity costs you incur from one choice, either going commercial version versus the free version. So we've got a project here called Tin Dog Dating Application. And here we could see just a little bit of detail about that project. So you've got a name, you've got a description, and the organization you can see here on the right is David Kent Cloud Solutions Lab Demo. Now the SCM, that's your software repository. For the sake of the demo, I've got the SCM type as manual, meaning locally on the file systems on this AWX machine. But typically you would set that up, the repository, to be your Git repository for the project. And then you would see a different layout for a Git repo versus what you're seeing here. And here you see templates. So each template is a run book, a playbook that we're going to be calling, and we can do things like change variables or provide a list of variables or a list of objects or JSON objects that would serve as the data inputs to these templates that you're calling. You'll note that we're building out in this configuration the entire infrastructure. And if you've done the Oracle Cloud, then you would recognize this. But if you're not familiar with Oracle Cloud, you can substitute resource groups with compartments. It's basically the same thing with a different name and slightly different characteristics, but the same end result is achieved. So we're building out our compartments, our VLANs, our subnets, our gateways, our routing tables, and it goes on from there. And then to look at an individual template, you can see that we've given it a name, we've given it a description and a job type. And we've selected a particular inventory. In this case, it's our demo inventory. And the project is Tin Dog Dating App. And we can see that there's an actual file that is referenced, 010_create_vcns.yaml, which is the magic that is actually going to build all this stuff. And here's our app. Tin Dog is a fictitious application that is built. It runs in the Oracle Cloud. It has a Kubernetes front end, and it has a database back end. And it's an application for your dog to find a date with another dog. And so you can see that we've got on the back end, we've got a storage account, we've got a database, we've got a container repository, a load balancer, we've got a web application firewall, we've got a Kubernetes cluster that is pulling the containers out from the repo, and then we've got three subnets within the VLAN that you see, which is a /16. You can see the public load balancer in this particular build is exposing the IP addresses that the WAF is presenting to the World Wide Web. For the disaster recovery environment, we've got, can you still hear me? Because the mic went offline for a moment. It looks like I lost the video too. So we've got the databases, the database servers, which we've got a test server, and then we've got a production server. We've got an RMAN appliance. We've got a batch, and we got a couple of batch servers. We've got a Tomcat VM, and then we've got a VM to manage updates. And you can see that the flow is for the front end or the web tier of the application. We build our containers on the Tomcat VM, and then we push those containers to the container registry. And then our Kubernetes service is then programmed with YAML files, which can also be managed from Ansible Tower. And it can pull those containers in to the cluster. And then the cluster, based on how is also configured by Ansible Tower with another script, would then push those containers out into the node pools. And the node pools in Kubernetes is where your compute is that runs the front end of the application. You can see that we've got a replication that takes place from the primary to this disaster recovery region, from container registry 01 in primary to container registry 01 in the disaster recovery data center, or region, I should say. We've got a DMZ that stretches across the two regions, and that's a compartment, that's an Oracle thing. Azure, you'd have two different regions. Two different resource groups. And you can see that in the disaster recovery region, we have a compartment called drcomp, where we have another database. And we're replicating data from the primary region to the secondary region. We've got a clone of the batch server, and we have another Kubernetes cluster, with another node pool. And you can see I've got dotted lines here. And then we've got another web application firewall running in the disaster recovery region, along with some virtual desktop out there running Microsoft RDS. Now, think in terms like this. Okay, in disaster recovery mode, everything on the bottom is shut down except for the database server that's receiving transactions from the primary region. So the only resource that is up and running 24/7 is the redundant database machine, but the Kubernetes service is also running, but there are 0 node pools associated with it. It's configured and ready to go. And should a DR test be required, or should there be a disaster, then you would fire off a run book, and that node pool would get created, and the Kubernetes cluster would then immediately begin to pull those containers and push them out to the node pools. You can even do a live clone of a VM from a backup that would be replicated between regions directly into the DR region, fire it up and use Ansible as soon as that machine comes up online, and modify its name, modify its configuration like its connection string, so it's connecting to the DR database rather than to the production database. And you could simulate by doing a simulated promotion of that DR database instance from standby mode to simulated production mode so that the DR test can be conducted. You can build your VDI, your virtual desktop environment right away from custom images or from backups if you're running VDI in the primary region. And you can build your web application firewall all on the fly, on code, and on demand with code, and only pay for those resources when you need them. And if this were a real disaster, then you would have a different run book that you would run, where that line that doesn't exist on the lower right would then be connected, and now you're exposing those IP addresses to the internet, and then presuming you're going to modify your DNS, now your pointers are going to point to the IP addresses that are being presented for this application in the disaster recovery region, and you're up and running. The thinking here is you're running regular disaster recovery tests all of the time, so that in the event that you do have a real disaster, you can recover. And as Earl had pointed out earlier in his presentation, and I was actually online that evening, cloud providers, and in this case it was Oracle, cloud regions go down, availability domains go down, failures happen in the cloud, and you have to be prepared to respond to these events. And not only prepared, but ethically, we're custodians of the data. We have an obligation to make sure not only that we're protecting the data, but that data is available to our functional users, and ultimately to our customers' customers, in this case, our students, our alumni, and our constituency. Now, another thinking you may want to approach here is role swapping. This I would consider to be the gold standard of disaster recovery testing. And what a lot of organizations get into the practice to over time, as they get this down pat, is, okay, I got my infrastructure running as code. Okay, now I've got my DR site running. Okay, now I'm doing monthly DR tests. Now I want to take it up to the gold standard. I want to role swap. So I role swap regions, and I make the secondary region the primary region, and the primary region becomes the secondary region, and it's fully automatic. First few times, guarantee you, it won't be automatic. But if you get really good at it, then this all happens in the background with code driven by Tower. I have some references here before I'm going to go into just a few live screenshots of AWX that I have up and running now in demo mode. We've got the DevOps handbook, Phoenix project, a couple of other references, but I also have at the very bottom two references, Kubernetes for developers and Ansible up and running. I used these two texts to make the deep dive into infrastructure as code. And these two books were invaluable to get me from where my knowledge base was at to where it needed to be so I could do my job in my new role. I also have some references to the pain I went through to get AWX running. Remember, open source does not mean free. All it means is the organization is not paying for commercial support and for a commercially certified, stable version of the product. Ansible Tower is expensive. It is a retail price, I recall, $13,500 for managing 100 resources. That's a lot of clams to shell out for a management product. For some organizations running AWX without having to pay that expensive price, and that's a per annum price, may be the right choice, but there's an opportunity cost that comes with that. You've got to support yourself, you've got to fix it when it breaks, and when it breaks and you can't fix it, your only method of getting support is to go to GitHub and to open up an incident on that. And then maybe somebody will respond to you in a day or two. So understand the risks that come with it. Do we have some questions?
Yeah.
Go ahead.
Yes, Joshua has stated, I'm all for testing DR, but switching regions sounds terrifying.
It is. The first time you do it, it's terrifying. I completely agree. It's not something you get to overnight. It's something you set as a goal and you work for. You eat an elephant a little bite at a time. Eventually, you're going to have consumed that entire elephant. You've got to crawl, walk, jog, run. You're not going to run day one. But I think it's a lofty goal that's worth achieving if you've got all the resources aligned to do it and if you have the grit and determination to get there. I worked at an oil and gas firm where, well, actually, first time I saw this was years ago when I worked at Chase Manhattan Bank, where you had to do it for regulatory requirements. So you either did it or you didn't have a job. But when I worked at an oil and gas company 5 years ago, I worked with a fellow where we did a role swap between the Houston and the Baton Rouge data center in a private cloud scenario. And the first time we did it, it was a mess. We did it on a weekend. And then we created a punch list of issues. And we then, for weekends that follow, and we shifted our work week where Monday and Tuesday we weren't working, but we were working Wednesday through Sunday. And we continued to work like this until we had swatted all the problems. And we had approved outage windows on the weekend in the evenings where we could do that role swap, and our constituency knew that we were going to be down as we were trying to get this process working. It took us 2 months, but after 2 months, we had a process that worked. And eventually it became a process of playing the run book, and in 30 minutes, the ERP application, in this case it was JDE, was up and running in Baton Rouge. And then the following month, a playbook would run and it would be up and running in Houston. And the playbook wasn't run by us, it was run by operations. And so we trained the operations people not how to write code. That was not their responsibility. It was our responsibility to write the code, but rather how to use the tool and what processes to use with calling the help desk, going down the escalation list, getting someone up out of bed in the middle of the night if something goes wrong. how do you actually do the role swap? And then it became an operations responsibility to manage those role swaps. Let me know if that helped you a little bit. And Edwin is watching if you want to have a follow-up on that. But that's basically how we were able to achieve that. Now, I have more references here, but you could see that we've installed AWX, which includes Docker. In this case, you can do it with Kubernetes, and there's one other containerization engine out there. I can't remember the name of it. And then I chose Docker as the container engine because it was just easier to get ready for this demo. You see Node.js is installed running on Red Hat. I did this in the Oracle Cloud on Oracle Linux Enterprise, which is a Fedora kernel. So most of the Red Hat stuff off the shelf, the RPMs, they run without any problems on a Oracle Linux kernel. And then you see I'm referencing some Git documents, and then there's a couple other fixes that I'm referencing here. It took me about 6 hours to figure out how to get AWX to install properly and to run reliably and to start it up and to shut it down. And then at the very end, I've got some, just a reference of starting and stopping this, because you've got to gracefully start and stop AWX. Otherwise, you could have problems either with the database that's running on the back end, or you could have a problem with some files that are left hanging around that then have to be going and manually clean up. Yes, go ahead.
Joshua responded, "That's great. Thanks for the presentation. We've used Ansible, but never AWX."
Sure. Go slow with it. One of the things I found as soon as I installed AWX was that it blew up my Python library, which was not fun. And that took about 2 hours to figure that out. And mind you, I'm living and breathing in the Python space all the time, and you may not be in that space. So take your time, but have the grit and determination and the tenacity. You will get there. Also, there's a wealth of help you can get from sites like Stack Overflow, and even doing posts on Git. I've done a couple posts on Git, and I've actually gotten real help from other developers that are not necessarily associated with Red Hat. So sometimes I get the answer faster from a peer developer by way of professional social media. So I want to take a moment and get to the live demo, and hopefully nothing has gone wrong here. First of all, let's go into, here we go. Did we time out? No, we did not. So we can see this is the tenant that's running. And if we go here and we go here, we've got a couple of databases, except I'm in the wrong region. So here we have, Zoom is in the way, so bear with me. Here we have the two databases running, the test database and the production database. And then in disaster recovery, we have the disaster recovery database running over here. In developer services, we have a container registry, and your container registry is by region. So in this scenario, this in this case, primary is US East. We've got container registry 01, which is the ingress point for all containers from birth until death. And then a script would run nightly that would copy any new containers or modified containers, or drop any containers that are being retired from the registry. And then we simply synchronize the containers between the registries. We have the Kubernetes clusters, and we have the backing node pools. And you can see we got this node pool running right here. And dropping a node pool is simply nothing more than running a playbook that would then remove this run book. And then the cluster service is still there, but the node pool is gone, which means that the meter stopped running the moment you dropped the node pool. And as Earl had pointed out in his presentation, the compute capacity in Oracle Cloud is dirt cheap. And we've got machine instances. These instances here represent the node pool that is running. There's one terminated one, but you can see we got 3 other nodes that are running in this node pool. And then we've got the batch 02. And then in east, we've got our Ansible Tower host. And we've got stopped machines. I was supposed to start those up for the demo. And you can see we've got our, running here, we've got our node pool in primary and our ESM and our Tomcat instance running here in test. And then in web production, I've got sitting here a couple of domain controllers. The actual tower, looks like my session timed out, so let me log in. By default, it's an HTTP connection. Remember, this is a demo. You would front this with a load balancer or a web application firewall that would do the SSL termination. This would never be done in production. So here you can see we've got our workflows. We got a workflow to modify the infrastructure, modify the network settings, scale out the KB clusters, start the test services, stop the test services. Again, this is just a hypothetical build situation. So if we, for instance, look at the workflow for modifying the network settings and we go to the visualizer, we could see that we've got 2 jobs that run concurrently. One is to update the network settings and the other is to update the security list. Consider this. In many organizations, you will build out your infrastructure to a baseline from code that's in the Git repository that's gone through a DevOps process and model or DevOps organization that with CI/CD that pushes your code out and your infrastructure is in a current state. Somebody goes in, consultant from company Acme Corp, and does a cowboy maneuver and mucks up a security list in the middle of the production day. I need to roll that back right away. What do? I go into AWX or Tower, I run the playbook, this playbook here, and it will reset everything back to baseline. Well, that's the easy one because we were there during the day when the consultant broke it. The other scenario that's more dangerous is somebody makes a change to the security or something else in the infrastructure. I don't know about it. And we've just opened up some ports that is dangerous. And now hackers are coming in trying to find 0-day defects into our infrastructure. Implementing a mindset where the infrastructure is code, I reset that every night because every night I run this script. That's about all I have time to cover. I wish I could talk more about this. But I must conclude because I know that I'm running out of time. Are there any remaining questions that we can address at this time? Okay, thank you. Then I'm going to go ahead and end the video call. I'm going to turn it over to the chair, and I thank you everyone for attending.
Thank you, Hank.
Thank you,
Have a great
Hank.
day, everybody.
Thank you, everybody. We'll see you all tomorrow.
Thank you, Linda.